How do I name, classify, and measure angles? There's an angle. You can draw it if you want to. I'm teaching you how to name, classify, and measure angles. If you can remember everything I say without writing it down, that's up to you. These are your notes. Somebody may already know how to name an angle, and they don't have to write this down. But if you don't know how to name an angle, and you think you might forget how to name an angle, then I would write this down. An angle is made up of two rays. Okay? In this picture, you've got ray XY, and you've got ray XZ. Agreed? Yeah. Those rays have a common endpoint, which is X. Those rays form an angle. X is called the vertex of the angle. Vertex, right there. When you're naming an angle, you use the angle symbol, angle. In this case, we're going to call this angle YXZ. You can also call this angle ZXY. What letter was in the middle both times? X. What's X also called? Vertex. The vertex. So when you're naming an angle, what letter always goes in the middle? Vertex. The vertex. Okay? Vertex always goes in the middle. If there's a number on the interior of the angle, any kind of a number. All right, this could also be called angle 3. This portion in here where the number 3 is, this is called the interior of the angle. Which means the rest of this stuff out here and out here, that's the exterior of the angle. So yes, you could call it angle X. Alright, I'm going to try to draw a protractor up here. What are you laughing at? I used to teach art, you know.
No way.
I did, and I got fired. All we drew was smiley faces, and I got fired. I love drawing smiley faces.
What's your favorite space? Mine's awesome face.
Alright, that kind of looks like a protractor, doesn't it?
Yeah.
Thank you. Thank you very much. Thank you. Thank you. Thank you. Usually he's got some here and here. Maybe a there and a there. There's your 0 and maybe 180. Okay?
Yeah.
This little hole that's directly below the 90, that's where the vertex of your angle goes. Agreed?
Yep.
That's where the vertex of your angle goes. And these dash marks and the 0 and the 180, that's where a side of the angle goes. All right? So there's a protractor laying over that red angle. Now, if the protractor's got two sets of numbers on it, it's got an inside arc number and an outside arc number. In this case, this is like, let's say this is 60. And then, what's the other one going to be? It's going to be 120. Okay. This angle, this red angle, is less than 90 degrees, isn't it? If the angle is less than 90 degrees, then we use the smaller of these two numbers, don't we? Okay? What's the measure of this angle? 60. Good. If we put a blue angle up here, and it goes here to here, and maybe on the, we got a 150 and a 30. All right, this blue angle, what's the measure of the blue angle now?
150.
150, right? We're not going to use the 30. The blue angle is greater than 90 degrees. Okay?
Yeah.
Now, let's put a point, I don't know, here, here, and here. And we're going to call angle A, B, C. Does everybody see it? Let's look for the measure of angle A, B, C. The measure of angle ABC. 90 degrees. How'd you get that? You found the difference between the 60 and the 150, didn't you? Okay, and that was how much? 90. Good. So that's 90 degrees. You could have found the difference between the 130 and the 120, couldn't you? Because that's 90 degrees as well. So when you're using the protractor and you're looking for one of these interior angles, just pick which arc you want to use and then take your largest angle and subtract a smaller angle on that same arc. Obviously, you're not going to take 150 minus 120, right? Don't do that. All right, you're looking for this angle right here in that case. This is your symbol for the measure of. This is red, the measure of. That's a lowercase script m. And there's your symbol for angle. This is red. The measure of angle ABC is equal to 90 degrees. Clear? Turn the page. All right, so a right angle has a measure of 90 degrees, doesn't it? A right angle is equal to 90 degrees. And then draw a little picture of a right angle. And it's got to have one of these in the corner, doesn't it? A little symbol for 90 degrees. Uh-huh. An acute angle. That's less than 90 degrees. Picture would look something like that. Less than 90 degrees. Obtuse angle. That's greater than 90 degrees. And then finally you got a straight angle. Straight angle that's equal to 90 degrees. Yeah, that's what I meant to say. I was just seeing who was paying attention. Thank you. Only one person paying attention. What do you think? Yeah. All right, let's talk about an angle bisector. Angle bisector. That's a ray. An angle bisector is a ray is a ray that divides an angle into two congruent angles. An angle bisector, okay? It splits an angle in half. So if you draw a picture of an angle bisector, you can draw an angle and say we call this ABC. And if you're going to bisect that angle, then you just take a ray and you split the angle in half. So something like that.
It has to be in half or can it?
Yes, it does. It's a bisector. An angle bisector. It's splitting it in half. Two congruent angles. Here's a symbol. This symbol right here, this little arc, and this little arc mean that those two angles are equal to each other. They're the same. You could say that angle ABD is congruent to angle DBC. So you know where this is going, right? Well, this is, yeah. Okay, that's what's called the angle addition postulate, that angle ABD plus angle DBC would equal angle ABC, wouldn't it?
Yeah.
Okay? Now, if you knew angle ABC and you subtracted CBD from it, you would be left with angle DBA, wouldn't you? Okay, it works just like the segments from last week. Two smaller segments added together equal the whole segment. In this case, the two smaller angles added together equal the big angle. Well, you're going to get something, let's see, like, let me give you an example today. You're going to get a picture, or if you're told that this angle right here, this big angle, all right, let's say that that big angle is 7x minus 5. And then you're told that angle ABD was equal to 3x plus 9. And you're asked to find the measure of angle DBC. Find the measure of angle DBC. All right, if ABD and DBC are congruent, what could you make this equal to? What can you make DBC equal to?
7x minus 5.
It's 3x plus 9, isn't it? So doesn't the small angle, 3x plus 9, plus 3x plus 9 equal the 7x minus 5?
No.
All right, so if you combine these two, aren't you going to get, what's that, 6x plus 18? 6x plus 18 equals 7x minus 5. If you solve for x, subtract 6x from each side, then 18 equals x minus 5. Add 5 to each side. And 23 equals x. So if 23 is equal to x, and we're looking for angle DBC, then isn't it going to be equal to 3 times the 23 plus 9? And that's what?
78.
Okay, 78 degrees. And what I want you to do, they're going to give you these, you're not going to get these pictures. You're going to get it in text. You're going to get it in words. All right? So make sure you draw the pictures and fill in the given information, just like you did last week when you were finding distance and midpoint. Okay? Questions on anything we talked about today? All right, your assignment for today is, it's going to start on page 41. (24 through 28). And then on the next page, up on the top, it says to copy the diagram, extend the ray, classify each angle as right, acute, or obtuse, and then use a protractor. Do everything that they ask there, but instead of using a protractor, I want you to just estimate the angle measure. Okay? So you're going to do 30 through 35. And then 38 through 42. 37 through 42. Alright, and it's not really that much. It's only like 17 problems, something like that. So starting on page 41, 24 to 28, then on the next page you got 30 through 35 and 37 through 42. Be sure you are checking the odds in the back of the book as you're doing them, and check Edline for homework.